This one right here.
Mm-hmm.
Okay, suppose that f of z, prove that this limit is that. If and only if that is that and that is that. Okay. Okay, so here's how you can proceed. So the let's see, do we have the definition of limit here? I guess you need a definition. I'll just go through it. That's
Yeah.
fine. Okay. So if and only if. So there's this statement. So basically there's these two statements. And then there is this statement. So, and if and only if means kind of a double arrow like that. And so if you're doing a proof, then typically what you're going to do, sometimes you can carry the if and only if all the way through. But typically what you're going to do is you're going to use this right here to, you're first going to show that, but I'm putting this arrow moving to the right because I'm going to show that this implies all that, implies both of those. Okay, so here's what you can do. So you can let epsilon be greater than 0, and the idea is that you want to come up with a delta that's gonna work for you in both of these situations. But what you're gonna do is you're gonna choose. Hold on, no. Okay, this means so we're allowed to use this right here. That means that there exists a delta greater than 0 such that this right here. Wait. Z minus Z naught less than delta implies that f of z minus u naught minus I of z naught is less than epsilon. Okay, that's just from the definition here. So what we're going to do for going this way, we're going to use, we'll call this a delta naught here, meaning this delta comes from this definition here. Okay, this comes from here. So we're going to, but we're also going to just choose the same delta for these two right here. Okay. Let's see, does that work? I should have thought more about this. Let's see, does that work? Yes, that's going to work. Okay, so we do have this implying this piece right here. So f of z is u plus iv, right?
Mm-hmm.
So that's going to be less than epsilon. But that implies that this right here, u minus u naught plus I times v minus c naught is less than epsilon. Which implies that what this is the square root of u minus u naught squared plus c minus c naught squared. And that, if you take either of those away, then you still have less than epsilon, which is basically this. And so what this, wait a minute. Yeah, so what this is saying is, what this right here is doing is this part here. Okay, so basically, I guess I should have said the strategy from the beginning, but the objective was to find a delta so that z minus z naught less than delta, or this, which is the same, which is equivalent to this right here, implies that this, the u minus u naught, is less than epsilon. And we kind of got that, okay? So therefore, there's the 3 dots. The limit as xy goes to x naught, y naught of u of xy equals u naught, okay? Because that u minus u naught is less than epsilon. Okay, so we pretty much have that implies the first one. And then you can do the same thing, except down here, just go this v minus v naught part. So instead of eliminating this one, you eliminate that one instead. You have this, and you get the other one. So similarly, by just going down to this step and then going to, instead of going to u minus u naught, you go to v minus v naught. Similarly, you're going to get this one. Yeah. Similar, you're going to get that one. Now, to go the other way, it's more tricky. So this is how you do the other way. So this is showing that that implies that. To go the other way, again, you're going to let epsilon be greater than 0. And but then you're going to use these two objectives right here. So there exists delta 1 and greater than 0, and a delta 2 greater than 0. Now this one corresponds to the u, and this one corresponds to the v. Oh, this should be a v here. Is that a typo in the book? Whoa. Okay, and this one corresponds to the v. That corresponds to the u. Such that, okay, so for the first one, now this, seriously, this right here is the same as just saying z minus z naught. That implies that u minus u naught is less than, now, but what you're going to do here is you're going to go epsilon over 2. Okay, so if epsilon is greater than 0, epsilon over 2 is greater than 0. So this delta 1 gets us less than epsilon over 2. And you'll see the reason why in a few minutes. And for the delta 2, that implies this. Also less than epsilon over 2. Okay, so and then what you're going to do is you're going to choose the overall delta to be the minimum of these two deltas. So delta 1 and delta 2. Right. So this one implies that both of those are true. Okay, and that implies that if you take f of z minus u naught plus iv naught, that is equal to, well, f is u plus iv. You get that? And that's going to be equal to u minus u naught, wait, plus I times v minus v naught. That's going to be less than or equal to u minus u naught plus v minus v naught. This is by the triangle inequality. And also the fact that the modulus of I is 1. Okay, so you're applying the absolute value property or modulus property, which is less than epsilon over 2 plus epsilon over 2. So those are both less than epsilon over 2 when you have this condition. And so there you go. So given epsilon greater than 0, there exists a delta. We should have to construct the delta this way so that this is less than epsilon. Okay, so we're done. So we've shown that both these conditions imply this one.
What is the meaning of the minimum? Like, is that choosing the smaller one out of one of them, or what you say?
The minimum is the smaller one. So these are both going to be numbers that are greater than 0. So for example, if so just example. So if delta 1 were 0.001 and delta 2 were 0.0005, then the minimum would be what?
0.005?
Yes, it's the smaller. That's the smaller one. Yeah. So those are both positive numbers. So one of them will be one will be smaller than the other, or they could be the same size. So if these are both 0.001, then the minimum is 0.001, right? They're both the same. So I guess there's a little bridge there to cross too. So if you're taking the minimum of these two, then being smaller, so like for example, let's say the smaller one was delta 1, okay? So then this would just read, so then this would be pretty clear right here. But if you're taking, so let's say the smaller one's delta 1, okay? But you have this delta 2 here. But if you're less than delta 1, if this is less than delta 1, then it's going to be less than delta 2, okay? So that's why the minimum works. Because if you're smaller than the minimum, then you're smaller than this and you're smaller than that, no matter what. And so these two conditions carry over. Okay, great.